So the topic for today's lesson is calculus of function of several variables. So calculus means you know that it involves derivative and integration and so on and so forth. But in today's lesson, we will focus our attention on derivative part, okay? Derivative of function of two or more variables. So here is the goal. By the end of this class, you will be able to find the partial derivative of a given function, evaluate partial derivative, and also find the second order partial derivative of a function in two variables. So these are the goals for this lesson, okay? You know, in your previous class in Calculus 1, suppose in Calculus 1 or Math 104, suppose you are given a function y equals f of x, then what you did is to find the derivative, you did this, dy over dx equals f prime of x. That's another way of representing the derivative. Now in multivariable calculus, this is function of one variable. Now in calculus 2, so if we are given function of two variable, for example, x and y, not y, this is, let's say, z equals function of x and y, then the issue here is that there are two independent variable, right, x and y. Because there is only one variable in function of one variable in calculus 1, you are able to find the derivative directly dy over dx. That's a total derivative. But in this case, since there are two variables, you cannot find the derivative of, with respect to both of the variable at the same time. So we do one at a time. So what we're going to do is we want to find the derivative with respect to x, which is represented by f sub x, and you can differentiate that with respect to y, which is represented by f sub y. Okay, notice that the notation here is in case of function of one variable, it is dy over dx, but in this case delta z over delta x, and this is called partial derivative. Partial derivative with respect to x, and here this guy is partial derivative with respect to y. Okay, and as we have two different symbols to represent the derivative in calculus 1, one is dy over dx, and you can also represent by f prime of x. So in the same manner, we have delta z over delta x and delta z over delta y. And if you want to use this another notation, it is f sub x, xy, or f sub y, xy. What it means is, in this case, we are considering x as our variable and y as a constant. That's the meaning of this. So in this case, we treat x as variable and y as constant. Okay, that's what it means. In this case, we treat y as variable and x as constant. Keep that in mind. When you see f sub x, it means we consider x as our variable and y as a constant, and so we differentiate with respect to. This is actually the marginal change. When there is a change by 1 unit of x, what is the change? in the function. That's what it is. Marginal change with respect to x. This one is marginal change. This side is marginal change with respect to y. So keep that in mind. Now let's try a few questions here. By the way, you need to recall all the formula that you learn in your calculus 1, okay? Power rule, product rule, quotient rule, derivative of exponential function, and derivative of logarithmic function. So you need to recall those formula. If you forget, I have just provided those formula here, and it should be with you in your handout. Okay, make this formula handy. You may need it anytime. Okay, now let's look at example 1, maybe part A. Okay, I'll do here. So the given function is 2x squared y cube plus 6x power 5 y power 4. Okay, that is the function. What we need to do is, for the following function, find the first order partial derivative. Okay, we want to find first order partial derivative, which is, remember there are two variables, right, x and y. So you cannot find the derivative of both of the variable at the same time. So we find one at a time. So f sub x, and then we find f sub y later. Okay, and if you want to write another notation, you can also write, let's say this is z equals to this one, then you can also write dz delta z over delta x, and in this case you can write delta z over delta y if you like. Now let us calculate the derivative. Okay guys, please listen very carefully for the next 1 minute. F sub x means we are considering x as our variable and y as a constant. So let me just write down all the constant here. So 2 is constant, y cube is also constant. All we need to do is we need to find the derivative of x squared. What is derivative of x squared? Can anybody tell me? Clearly, using power rule, it is 2x, right? So this part is done. Plus 6 is constant, y4 is constant. I just write those constant as it is. Now I need to find the derivative of x to the power 5, and the derivative is 5x power 4. That's it, done. It looks a little ugly, so let us write in a nice way, which is 4xy cubed plus 30x power 4 y power 4, done. Now let's look at this. Delta z over delta y, and represented by f sub y. What it means is we treat y as variable and x as constant. So let me just copy the constant term. 2x squared is constant with respect to y. So y cube, derivative of y cube is 3y squared, right? Plus 6 is constant, x power 5 is also constant. Now you need to find the derivative of y power 4, which is 4y cubed, because we are finding the derivative with respect to y, which is 4y cubed. That's it. So your answer is 6x squared y squared plus 24x power 5 y cubed. Done. Any question, guys? Let's try one more, just in case if you still have confusion. Let's try one more. Let's say part C. So we have a function w equals f x y z, which is x squared minus xy plus y squared That is the given function. Oh, by the way, in this case, you can write simply f sub x, or you can also represent that by f sub x, xy. You can write this way too if you like, okay? For this guy here, you can write simply f sub y, or you can write f sub y, x and y. It doesn't matter. So whichever you like, you can write it down. Now there are three variables. So we'll have three first order derivative here. Okay, one first order derivative is f sub x, which means delta w over delta x. Another would be f sub y. We need to find the derivative with respect to y, which means delta w over delta y. And f of z, which means delta w over delta z. Can you guys try this on your own? Now, if you want to consider x as a variable, then y and z will be constant. So let me just write it down. X squared, because we treat x as a variable in the first case, so that will be 2x, the derivative is 2x, minus y is the variable, and derivative of x is 1. Derivative of x with respect to x is 1, plus derivative of y squared with respect to x, this is a constant 0. Derivative of x, 2yz with respect to x, again 0 because there is no x. And this will be 0, this will be 0. So your answer is going to be 2x minus y. And I want you to complete the other two. Thank you guys. You already provided the answer for both of these in the chat box. I'm just going to copy it. But anyway, let me show it how to do it again if you still have questions or confusion. Now in this case, f sub y, it means we treat y as a variable and x and z as a constant. So the first term is x squared. With respect to y, it is constant, so you'll get 0. With respect to y, this is negative x is constant, derivative of y is 1, plus derivative of y squared is 2y, derivative of 2 and z is constant, derivative of y is 1, and derivative of 2z is squared with respect to y, there is no y, 0 and 0, so your answer is going to be negative x plus 2y plus 2z. And with respect to z, so x squared is constant, 0, there is no z in the second term, 0, no z in the third term, 0, there 2 and y is constant, derivative of z is 1, because derivative of z with respect to z is 1, plus 2 derivative of z squared is 2z, plus derivative of z is 1. So you're going to get 2y plus 4z plus 1. Done. Any questions so far? So do you want to try one of these two just for fun? Part B or C? B or D? Okay, guys. I trust that you are able to do this part B and D by yourself. And if you need help, then I will provide you the solution in my lecture note in Canvas. Have a look. And now let's look at one application questions, okay? How we can apply this skill that we just learned to solve some of the real world problems. And let's consider Cobb-Douglas production function. It is a very famous production function, and you can actually, if you Google it, then I think you can learn more about it in Wikipedia or in Google. So the basic idea, I mean, the basic function for Cobb-Douglas production function is given by f of xy equals ax raised to power b and y raised to power 1 minus b. Notice this, okay, where b lies between 0 and 1. And a and b are both positive constant. X stands for the cost of labor and y stands for the cost of capital. And this function is known as Cobb-Douglas production function. And here is one example. A certain country's production in the early years following the World War II is described by the function, production function Pxy equals 30x raised to power 2 over 3, y raised to power 1 over 3, when x unit of labor and y units of capital were used. In part A, we want to compute this partial with respect to x. Okay, we want to compute the production, which is actually the marginal production with respect to x, and marginal production with respect to y. Productivity. Is it production? Productivity. Production. Okay. Now let's look at part A first. I want to copy the question first, the function. The function is Pxy equals 30x raised to power 2 over 3, y raised to power 1 over 3. In part A, we want to find P sub x xy, which means we want to differentiate, we want to find the partial derivative with respect to x. And you know how to find that, right? Let's try. With respect to x means x is our variable and y is constant. So 30 is constant and y power 1 over 3 is also constant. I just want to write down the constant first, and then I'm going to use the derivative power rule for x, which is 2 over 3 x raised to power 2 over 3 minus 1, which is 2 over 3 minus 1 is going to be negative 1/3. That's it. And P sub y, which means it's a production function, marginal productivity, marginal production with respect to y. In this case, your constant will be x, 30x raised to power 2 over 3 are constant. And now use the formula power rule for y, which is 1 over 3 y raised to power 1 over 3 minus 1, which gives you negative 2 over 3. Okay, so that means what we get here is, let me just push this a little bit further. So your answer is going to be, if you simplify it, you're going to get 20 x raised to power negative 1/3 and y raised to power 1/3. Okay, that's your partial with respect to x. Now partial with respect to y, we already calculated. Let us simplify because it looks ugly. So you're going to get 10x raised to power 2 over 3 and y raised to power negative 2 over 3. Any questions so far? Okay. Now part A is done. Part B. Find the marginal productivity of labor and the marginal productivity of capital when the amount expended or amount spent on labor and capital was 125 units and 27 units. Okay, so part B, marginal productivity with marginal productivity of labor. So labor means which one, X or Y? So let me see. X stands for the cost of labor. Yes. So basically, this one means we need to find when X is 125 and Y is 27, what is that partial derivative with respect to X? That's all we need to find. Okay. X is 125 and Y is 27. So let us calculate this. So that's going to be 20. X means 125 raised to power negative 1/3. Okay, here is the function that we calculated. We just substitute the value. X is 125 and Y is 27. So Y is 27 raised to power 1/3. So I need your help. Use your calculator and let me know what you get. In the same manner, we can find marginal. I want you to find this marginal productivity of capital, which means we want to find P sub Y, partial with respect to Y, 1 to 5, 27. X is 125, Y is 27. Just substitute the value in this one. Substitute the value here. So you will get 30. X means 125 raised to power 2 over 3 and 27 raised to power negative 2 over 3. And let me know how much do you get. Yeah, I was checking how many of you are paying attention. This is actually not 30. This is 10. As you can see here, it is 10, not 30. Yeah. So when it is 10, you're going to get 27.78 approximately. Okay. So we got the marginal productivity of labor and capital. Now in part C, what we are supposed to do, part C, let's look at the question. So the government have encouraged capital investment rather than increase expenditure on labor to increase the country's productivity. Okay. Now, the country wants to increase its productivity. Okay. The country wants to increase its productivity. So what is your advice to the government? Increase 1 unit of, increase the capital or increase the labor? What would be your advice based on the result that we got? Notice that when you increase, what this marginal productivity means is that if you increase the labor, because X represents labor, by 1 unit, the production will increase by 12 units. That's the meaning, right? If you increase the labor by 1 unit, keeping the capital same, constant, the production will increase by 12 units. Now, if you increase the 1 unit of capital, keeping the labor constant the same, then the production will increase by 27.78 units. So if the country wants to increase the production, then your advice would be what? Increase labor or capital? Clearly capital, right? Yes, capital. Yeah, the government should increase capital if, because it results in it results in increase in, it results in increase in production at a much faster rate than increase labor. Okay, so that's the answer. Any questions so far? All right, so if no question, then let's move forward. Now we already learned how to find the partial derivative, first order partial derivative. Now we want to learn second order partial derivative as well. Now I want to take you to calculus 1 just for 1 minute if you don't mind, okay? In calculus 1, suppose you are given y equals f of x, then dy over dx is f prime of x, we know that. And if you want to find the second derivative, that's how you write, right? D notation is this, or you can write double prime of x. In the same manner, in calculus 2 here in this course, suppose you are given z equals f of xy. So delta z over delta x will be f sub x. We know that. And we want to find the second derivative of this as well. Okay, there will be 4 second order derivative for this, by the way. And we'll look into that in a minute. And one of them is d2z over dx squared that's one of them. There are 4 different second order partial derivative, and one of them is this. That's how we do. Okay, let's look at here is the notation. You can actually look at this by yourself, but when we are solving this problem, then we will look into the notation as well as how to find it. Okay, so let's try part A, and you will try part B on your own. Or do you want me to try part B or A? Which one you want me to do here right now? Or which one you want to work together with me? Part B or part A? Let me know. Okay, you guys want to do part B together with me. Okay, that's great. All right, let's try part B. So Z is given. Let me just copy the question. F xy equals x squared y cubed plus x power 4 y plus x e power y. Now, in order to find the second order partial derivative, see here the question is for the following function, find the 4 second order partial derivative. In order to find the second order partial derivative, you must find the first order. So let us find first order first. First order means one is f sub x, another is f sub y. We know that. So f sub x it means we are trying to consider x as a variable, y as a constant. Therefore, this guy will be y cube is constant. So you simply write derivative of x squared, which is 2x. So I'll write 2x y cube plus this guy will be x is our variable, which is 4x cube, and y is constant. I just copy that constant as it is. X is our variable. Derivative of x is 1 times e raised to power y. I simply write ey. Any questions so far? Now let's look at partial with respect to y. So it means we treat y as our variable and x as a function. So that's gonna give me y is our variable, which means this will be x square and 3y square. So I'll write 3x square y square plus x power 4 plus x e raised to power y. Because x is constant, just copy as it is, and derivative of e raised to power y will be the same, e raised to power y itself. So that's it, first order derivative. If you want to write this delta notation, it is actually delta z over delta x. This is your delta z over delta y. Now, second order partial derivative will be, one way is to do this. You can find, we have this, okay, we have this f sub x already. You can differentiate this function with respect to x, or you can differentiate this function with respect to y, right? For this function, now this is the function that we want to consider, and you can differentiate that with respect to x, or you can differentiate with respect to y. So let's try that. So here, if you want to differentiate with respect to x, then that means y is your constant. So 2y cube is constant. I just copy as it is. Derivative of x is 1. Now, second term, 4y is constant. Derivative of x cube is 3x squared. And there is no x in the last term, so that will be 0. So your answer is going to be 2y cube plus 12x squared y. That's it. And in this case, consider the same function. Now differentiate with respect to y. So that means treat y as a, consider y as variable and x as constant. Okay, so this function, this f sub x function is this one. Now for that function, you differentiate with respect to y. That means you consider y as our variable and x as a constant. So let us try that. So y is variable. So that's going to be 2x is constant. I just copy as it is, and the derivative will be 3y squared plus y is variable and x is constant. 4x cube will be constant. Derivative of y is 1. And derivative of y is simply e raised to power y. So the answer is going to be 6xy squared plus 4x cubed plus e raised to power y. Okay, done. Any questions so far? Now I want you to try this on your own, this side here. So all you need to do is find f sub y is there. Okay, differentiate this function. This is a function now. Differentiate that function with respect to x. Differentiate that function with respect to y. Maybe I'll do y first, and then we have that function and we differentiate with respect to x. So let's try this. So in this case, f sub y is already there. So we differentiate that with respect to y, means y is our variable and x is constant. So 3x squared is constant. Let me copy as it is. Derivative of y squared is 2y. And y is our variable and x is constant. There is no y, that means it will be 0 plus x is constant, and so I just copy as it is. A derivative of ey will be ey by itself. So your answer is 6x squared y plus x e raised to power y. Now for this guy here, we consider x as our variable and y as a constant. So this function is already there. So all we need to do is, x is our variable, so y is constant. So 3y squared constant, I just copy as it is. Now derivative of x squared, which is 2x. Does that make sense to everyone? 3y squared, because we are differentiating with respect to x, that means y is constant. So 3 and y squared constant, I just copy as it is. and derivative of x squared is 2x, plus derivative of x power 4 is 4x cubed, and derivative of this guy will be e to the y by itself. So if you write this nicely, 6xy squared plus 4x cubed plus e raised to power y. That's it. There are 4 second order partial derivative. Now, one thing though, I want you to look at very closely this one and this one. Did you notice something interesting there? And if you notice something interesting, what is that? Same result. Yes, thank you. So we notice that, you see, this result here and this result are same. Is it a coincidence, or do you think it will always works? And by the way, this result is always true. Okay, this is always true. Keep that in mind. So we have seen this in one example, but maybe you can try with other example as well after a few minutes. Okay, one more thing. This is the symbol in term, representing the second order derivative in the form of f. Now the same, we can use the delta notation for this. Okay, here we use the f notation. If you want to use the delta notation, what it means is we have this delta z over delta x, and we differentiate this guy by delta over delta x again. So therefore, this is actually d2z over dx squared. If you want to write this in delta notation, that's how you write it down. And for this guy, what we did is we already have delta z over delta x here, and we differentiate that with respect to y. So you can write this as d2z over dy and delta y and delta x. So you can use this symbol if you like. And in this case also, what we did here is that we already have delta z over delta y, and we differentiate that by delta y again. Therefore, you can write this as d2z over dy squared. And in this case, also, we already have delta z over delta y, and we differentiate that with respect to x. So if you want, you can write delta 2z over delta x delta y. You can write that way too. So now, which symbol do you want to use? Which symbol you find easy, the delta notation or the f notation? It's up to you. You can choose whatever makes your life easy. To be honest with you, most of the time I think using the f notation is much more simpler, right? Okay, so you can do that. Do you have any question? So do you want to try this example 3 part A just for fun? I want you to find f sub x, f sub y. I want you to find f sub xx. This is the first order now, first order, and also second order. So second order, there are 4 second order, f y y, and then fxy and fyx are same, so you can just calculate. Anyway, let's calculate this fxy and fyx. Let us calculate this. Okay, I want you to try all of these right now. And if you know how to do this, if you understand this, then that means so we are done with this section, and in the next lesson we will apply this concept to solve real world problems related to maximum and minimum values. That's the goal in our next class. But right now I want you to complete this part A. Okay, and try this, and if you need help, then you can look at my lecture note, I mean the solution that I provide in Canvas.